In this example, we have that if cosine of theta is equal to 5 over 13, and it is known that 3 pi over 2 is less than theta is less than 2 pi, then we will find what sine of 2 theta, cosine of 2 theta, and tangent of 2 theta are equal to. In this situation, we are told that cosine of theta is equal to 5 over 13. However, unfortunately, I am not familiar with the ratio of 5 over 13 from the unit circle. Therefore, I do not know what the value of theta is as a value from the unit circle. Thankfully, I do not need to know what the value of theta is. I just need to know where theta is located. And with the second line of information that 3 pi over 2 is less than theta is less than 2 pi, means that I should know that theta lies within quadrant 4. So, if I draw a quick little graph here, we have that theta is an angle measure somewhere in quadrant 4. And so I'm going to draw a line to represent where the terminal position might lie, and I'll create a right triangle to the x-axis. Although this is the standard position for theta, I can technically consider this as its reference angle alpha, and instead solve our values considering that. Since I know that if cosine of theta is equal to 5 over 13, then also cosine of alpha is equal to that. In this case, I'll just use theta for simplicity. Now, if we want to find sine of 2 theta, and cosine of 2 theta, and tangent of 2 theta, it would behoove us to try to at least determine what sine of theta is as well. Because we know cosine of theta is 5 over 13, that means in this triangle I can say the adjacent side is a 5, and the hypotenuse side is a 13. So all we need to solve for is the adjacent side here, which is 13 squared, the hypotenuse squared, minus the adjacent side squared. And thankfully, this actually is a Pythagorean triple if you happen to notice it. If not, this gives us the square root of 144, which is equal to 12. More specifically, however, because this is representing the opposite side of a reference angle in quadrant 4, I should represent this as a negative side length. So I'm going to represent this as a negative 12 because of where we are in quadrant 4. From there, then, I can establish that sine of theta is therefore equal to the ratio of negative 12 over 13. And we are already told of cosine of theta being 5 over 13. Those should be the only two pieces I really need here. I may want to know tangent of theta, which is the opposite over the adjacent. So that would be negative 12 over 5. However, it's not technically necessary in this problem. You'll see why in a moment. For sine of 2 theta, though, knowing this information, sine of 2 theta, if I apply the double angle identity, is 2 sine of theta times cosine of theta. And we now know what sine of theta and cosine of theta are. Sine of theta is negative 12 over 13, and cosine of theta is 5 over 13. If you simplify here, 2 times negative 12 times 5, that is negative 24 times 5, which is negative 120. Divided by 13 times 13, which is 169. For cosine of 2 theta, we can use a few different formulas or identities to solve this because we do have a few different ways to represent cosine of 2 theta. However, the one that I will elect to use here is 2 cosine squared of theta minus 1. The reason that I chose that version of this double angle identity, note that the only value that we need to know in order to use this identity is cosine of theta. And cosine of theta happens to be the ratio that we were provided at the beginning of this problem. Meaning, if I happen to have made a mistake when evaluating the triangular representation of this angle measure in quadrant 4, then that mistake is not going to follow into this part of the problem because this isn't using any of the calculated values. It's only using the provided ones. However, if you choose to use any of the other identities for cosine of 2 theta, you should get the same result. Here I'll have 2 times cosine squared, which cosine here is 5 out of 13, minus 1. If you simplify that, 5 divided by 13 squared is 25 out of 169. Multiply that by 2, you get 50 out of 169. And if you subtract that from 1, or minus 1, you'll get minus 169 out of 169. 50 at minus 169 gives you negative 119 divided by 169. Now, if you solve for tangent of 2 theta, I said earlier that we technically don't need tangent of theta to solve this, even though the formula for the double angle identity of tangent is 2 tangent of theta divided by 1 minus tangent squared of theta. So it seems like the only one we do need is tangent. And if we do use tangent here, 2 times tangent, where tangent is negative 12 out of 5, divided by 1 minus negative 12 out of 5 quantity squared. If we simplify this, in the numerator we'll get negative 24 out of 5. And in the denominator we'll get 144 divided by 25 subtracted from 1. 25 minus 144 is negative 119 divided by 25. If you simplify this by either multiplying by the reciprocal of the denominator or multiplying both the numerator and denominator by 25, you should get here 120 divided by 119. Positive because the two negatives cancel each other out. So that's fine. However, I didn't need that. The reason I did not need that is because tangent of 2 theta is also defined as sine of 2 theta divided by cosine of 2 theta, both of which we've already solved. Sine of 2 theta we said was negative 120 out of 169, and cosine of 2 theta we said was negative 119 out of 169. That will also give you 120 divided by 119. Same results. Just takes a little bit less time. One final note about this problem. Even though it doesn't ask us this, it is good to consider where this angle measure would end up lying. If you look at the values that we got for sine of 2 theta, cosine of 2 theta, and tangent of 2 theta, don't exactly care about the numerical value per se, but more just the sign of it. Sine of 2 theta came out to be a negative ratio. Cosine of 2 theta came out to be a negative ratio. And tangent of 2 theta came out to be a positive ratio. There's only one quadrant where that could be true. The only quadrant where both sine and cosine are negative, whereas tangent is positive, is quadrant 3. Meaning, even though I don't know what theta is or what 2 theta is, I at least now know that 2 theta is an angle measure that would lie within quadrant 3.